Now question number 5, 6 and 7 would be exactly same. You can do them yourselves. Look at question number 8. Question number 8 says that find the range of values of k first of all. So if it is range, the discriminant should be either bigger than 0 or less than 0, that we expect for this equation. And the condition is that the equation has real roots. Now if the equation has real roots, that means it is not specified whether real repeated or real different. So for self side we will have discriminant bigger than or equal to 0, both of the conditions merged together. And then they are saying once you are done with this, you use this condition b square minus 4ac bigger than or equal to 0. You find the range of values of k. As soon as you are done with that, proceed to finding the roots, but you cannot find the exact values of the roots. It would not be like you get the value of x equal to 1 or 2 or 3 or 4, but find those roots in terms of k. Now this is the only different thing in question number 8, that is why we are doing it together. So find the answers, find the values of x, but not there would not be fixed values, they would depend on k, they would have k involved in those values. Let's see how it works. First we take the equation, we simplify it, we take the value of a, b and c. We plug them into the condition which is b square minus 4ac bigger than or equal to 0. We simplify it, so we get 4k squared minus 4k squared cancelled here. So we are left with 8k plus 24 bigger than or equal to 0, which means 8k is bigger than or equal to negative 24. We simplify it, that means k is bigger than or equal to negative 3. That's the range of values. It means k can be negative 3. It can be any number bigger than negative 3. That is negative 2.9, negative 2.5, negative 2, negative 1, negative 1, 0, 1, 2, 3, and so on and so forth up to positive infinity, right? We got the range of k. Now we need to find the roots, but in terms of k. So our answer should have k in it in the end. So for finding roots, we use the quadratic formula, which is minus b plus minus the square root of b square minus 4 times a times c divided by 2 times a. We plug all the values. We already know the answer for b square minus 4ac. When we simplified it, we got 8k plus 24. So we just put that 8k plus 24 here, right? If we take 4 as a factor out of it, we will be left with 2k from 8k and plus 6 from 24, right? The square root of 4 is 2. So now we factor out 2 from the numerator and divide it with the 2 that we have in the denominator. Our simplified answer is negative k plus minus the square root of 2k plus 6. That means our first x value can be minus k plus square root of 2k plus 6. The second value could be minus k minus the square root of 2k plus 6. These are two values, these are the two roots that we get, and they both have k in it. That's what they asked us. They asked us for roots in terms of k. We got roots in terms of k. Look at question 9. It says that show that the roots of the equation are not real if p is bigger than negative 3 upon 2. So you will take the condition of non-real roots. Non-real roots means b square minus 4ac less than 0. You simplify this and your end result would be p bigger than minus 3 upon 2. So you just take the condition, you simplify it, and you will deduce that p is really bigger than negative 3 by 2. Look at question number 10. It says that the equation has two equal real roots. So for two equal real roots, set discriminant equal to 0 and then find q in terms of p. So as soon as you simplify that, your discriminant will be in terms of q and p. You simplify the equation, you will get the answer of q in terms of p. So you will get the value of q and that value will include p in it, right? Do question number 11, which says that this equation is satisfied by two distinct real values of x. It means two different real values of x are solution of it. That means we have two different real roots. That means discriminant should be bigger than 0. You set discriminant bigger than 0 and you will find the value of k. Question number 13 says that show that the solutions of this equation are real for all real values of k. So now this is something important that you need to know. Whenever they say for all real values of k, that means the discriminant no longer depends on k. the discriminant will be, they say that this will have real roots, right? The solutions will be real. It means the discriminant will be bigger than or equal to 0. It will be non-negative. It would be either positive or it will be 0 without the influence of k. It means k will have no contribution in it. So when you simplify this question number 13, when you simplify the discriminant of this, the discriminant will have no k in it. K will get cancelled out. When k gets cancelled out, you would say that there's no role, no influence of k in our discriminant. So the discriminant is a positive value without k. That means it is valid for all values of k, doesn't matter. Question 14 says that given that x times x minus 2 equals to t minus 2, find x in terms of t. So you need to find the roots, use the quadratic formula, find the answers in terms of t, hence deduce the range of values of t for x to be real. Then use the condition of discriminant bigger than or equal to 0 and find the values of t. Question number 15 says that this graph cuts x-axis in two places. Very simple. If it cuts x-axis in two places, that means two real different roots. Use discriminant bigger than 0 and find the values of c. Question number 16 says that find the values of p when it is tangential to the curve. This is something that we need to talk about. Tangential means cutting at one single point. Whenever a curve and a line meet at a single point, it's tangential to one another. So if this is my curve and the line is just touching it at one point, we say it is tangential. Okay, so whenever they tell you that a curve and a line or a curve and x-axis are tangential with each other, just go and use discriminant equal to 0, right? Because it has one real solution, or we say repeated real roots. Okay, then question number 17 has two parts. It says that find the values of p for which this equation has two equal roots. Two equal roots means discriminant equal to 0. Show that the line x plus y equals to q will intersect the curve this in two distinct parts if q square is less than 2q plus 5. So we take these two equations. First, this equation is in terms of y and that equation is also in terms of y. So we equate these two equations. We equate them and we have a single equation. We take values of a, b and c from that single equation and use the condition of the discriminant that they have given, which is two distinct points. If two distinct points means discriminant bigger than 0, we set discriminant bigger than 0 and this will get reduced from it. Maybe we will do it in the next recording. I'm just walking you through the exercise in this one. In question number 18, it says that find the value of c such that the straight line, this equation, is tangential to the curve, this one. So you take this value of y, which is 2x plus c, and put it equal to this one. So we have y equals to 2x plus c. We take 2x plus c and put it equal to 3x square minus 6x plus 5. So now we can make a single equation because this is also y, this is also y. Both of the values should balance each other. Now we have 3x square minus 6x plus 5 minus 2x minus c equal to 0. So that says 3x square minus 8x plus 5 minus c equal to 0. Now my a value is 3, b value is negative 8, c value is 5 minus c, right? So we can give it a different value c or something, right? Different identity or name. They say that this is tangential to the curve. Tangential means discriminant should be equal to 0. So you take the values of a, b and c, plug them in the discriminant, set them equal to 0, find the value of c. Question number 19 gives you one equation with another curve. They say, okay, what are the possible values of m? Find the values of m if they two. So you take these two, merge them, make a single equation, have two distinct intersections. That means set discriminant bigger than 0. They meet at one point, means set discriminant equal to 0. They do not meet at all, means set the discriminant less than 0. Find the values of m. The similar way you have to do the exact same in question number 20, 21, 22, and 23. Let me know if you have any problems. We'll discuss them in the next part.